students, and welcome to the class. The first thing you need to do is you need to go to A plus students.com, right? That is the website. You go to the website, then we need to select a subject, right? The subject is math. We're having our math class. Subject is math, and your grade is grade 3. Okay, so once we are on the website, you've selected the subject and we are in grade 3. We need to go to the chapter for today, right? So in grade 3, we need to find the chapter. The name of the chapter is, okay, the name of the chapter is Symmetry. Okay, and the chapter number is, I'll just give you the chapter number, and the chapter number is 28. Chapter number 28. And the lesson number we have for today is, lesson number is 3. And the name of the lesson is Rotational Symmetry. Okay. I hope you all have joined the math grade 3, found the chapter number 28, that is Symmetry. And we need to go to lesson number 3. Okay. I'll just connect with you on the same page. Okay. I'm on Symmetry and we are doing lesson number 3, that is rotational symmetry. Okay, let's see what we can do in rotational symmetry. Before studying, let's see what is rotational symmetry. The term rotational symmetry, we can break these terminologies into further explanation, right? We know that symmetry is a line where the object is the same on the left side and on the right side, right? That is symmetry, from the line of symmetry, right? Rotational refers to the word rotation. Rotation means if I would pick up an object, right? If we have this arrow, right? This arrow can be rotated. This arrow can be drawn like this over here, right? Or if we do another rotation, can we say, can it go downwards? Right? Or can it go towards the left? We can say that if this was our original shape, if we rotate on towards the right side, right? If we rotate on this towards the right side, I'll just explain you what right side is, right? So can we say this becomes the same shape? That becomes the same shape, right? And again, if we rotate towards the right side, it still stays as the same shape. And again, if we rotate one more time, can we say it still stays as the same shape? And if we rotate it again, can we say this is still the same shape? So that means this shape A can be rotated in multiple ways, right? It can go to B, it can go to B, it can go to C, or it can go to D, but it will still be the same shape, right? So in case of symmetry, rotational symmetry, what we need to see is, since we know a circle is always made up of how many degrees of angle? Can anyone tell me? A circle is made up of 360 degrees, right? The angle of the circle is 360. Just remember this word, 360. The circle has to be 360, okay? So if I would say I need to explain it to you, right? Uh, that means for every direction change, a circle can be broken down into four parts. That would mean a circle can be broken down into four parts, right? Let's suppose if we have a pizza, and a pizza has four slices in it, right? If a pizza has four slices in it, so what we can say is, if this was our starting point, right? Or we can say it's a clock. We have a 12 over here, we have a 3, we have a 6, and we have a 9, right? If we are moving in the direction of the clock, if you're moving in this direction, right? So this is known as clockwise direction. Okay, I will be using these terms, so that's why I'm trying to explain these terms. But if you're going against the clock, that would be against the clock. For the against, we use anti-clockwise direction. Okay, these are the two things we need to remember. If you're going in the direction, if you're facing forward and you are turning from the right side, that means you're going in the clockwise direction, right? But if you're turning from the left side, that means you're going against the direction of the clock. You're going from 12 to 11 to 10 to 9, right? The hours, right? Let's look at an example, our everyday daily life example, right? We can use this example. Let's suppose you're at school and you have a morning assembly, right? And your PE teacher is giving you some instructions. Let's suppose you're facing the assembly, right? I'll just make 2 or 3 kids over here. Okay. If we have students standing in the assembly, we'll write this is student A and this is student number B, right? So what happens is, when your PE teacher gives you an instruction to about turn, right? So what happens is, one of the student can rotate from, sorry, this student can rotate from this side, right? I'll just show you the rotation, right? The student can rotate from the anti-clockwise direction, right? This student rotates from this direction, and eventually the student comes where? This student would about turn and they would face backwards now, right? But if we look at the other case, if one student was turning from the left side, right, from the left, and they are facing this position now. First they were facing this position, right? But the other student, what can happen to the other student is, this, rather than turning from the left side, the student can also turn from the other side. That means he or she can turn from the right side, right? So the student can turn from this direction also. That means they are going in the direction of the clock, right? So can we say the student is going in this direction, and the student is, first the student was facing forward, now the student is facing southwards, and the student is turning from the right side. Okay, now let's see if they turn 180 degrees. 180 degrees happens when you do an about turn in your assembly. Now the student is facing over here. So what we can see in either of these cases is, if you rotate from the right or you rotate from the left, an about turn means first you were facing forward, now you're just facing backwards, right? So we have to see, but the student hasn't changed. If you're standing in an assembly and you turn from the right, now face backward, you are still you, right? So let's see what is rotational symmetry. Okay. Okay, let's see in the questions. What we can do is, the question says we have two options for this, yes or no. So let's see what our answer can be. For the first question, we'll pick either a yes or we will pick either a no. Okay. Question number 1 says, does this picture have a rotational symmetry? Okay. Rotational symmetry means that if we rotate this shape, okay, if I'll select this shape, I'll make a copy of it, and let's try to rotate it from the right side, right? Does this shape look exactly like the, okay, if this was shape number A, the original we had, right? Does the shape number B looks like shape A? So we need to see that after turning this shape, will it still look like the original shape? Okay. Or if we have this shape and we rotate it, sorry, and we rotate this, sorry, let me paste one more. And if I say in shape C, I do this, does it still look like the original shape that was shape A? That's is shape C in the same direction as shape A? No, they are different directions because this is going in this direction and this original shape was in this direction. This is downward, right? So wherever we move this shape, unless and until it comes back to the same position, right? It will not have a rotational symmetry because the original shape is pointing towards the right. But if we're starting to rotate the shape B, it's pointing downwards. Shape C, left side. So there will be only one position, right? That means we say the shape does not have a rotational symmetry. There is no rotational symmetry because that means if we rotate the shape does not look the same. It has to look the same. Okay. We'll also get some examples where they will have a rotational symmetry, right? So if I would do another option, then we click on to the next question. The question says it has a shape and we've been asked whether this shape has a rotational symmetry or not. Okay. So we'll keep the options at the bottom. We'll pick the correct option later. I hope you have joined the class. Okay. Thank you. Let's start. Let's continue with this. So if we have this picture, right? So we have been asked whether this shape has a rotational symmetry or it does not have a rotational symmetry, right? So let's see what rotational symmetry can be. So for our convenience, we label this point as A and this point as B and this point as C, right? For our only reference. So if I rotate this shape, okay, so if I rotate it from the right, let's suppose 90 degrees, right? Or from the left, does the shape still look exactly the same? Even though the point A from here came down over here, but what we can say is the shape is still the same, right? Even if we do this, we rotate it 180 degrees. The point A is down, but the shape of this shape is still the same, right? A, B, and C were just our reference points, right? Irrespective of these points, if I remove the points, even after doing the rotation, in this case, we moved downwards. In this case, we moved 180 degrees. Can we say that the shape is still the same? Has the shape changed? Even if, yes, because it looks the same in each direction, right? So this means that it has this rotational symmetry. Yes, it does have rotational symmetry. So we click onto yes. Okay. Yes, there is rotational symmetry. Okay. Because as per your answer, the shape looks the same. Even after rotation, it's still the same, right? This was question number 2. Let's try another example. Okay. Okay. This would be a little difficult, but let's try. The third question says, does this shape have a rotational symmetry? I'll just copy the question over here. You'll have a better idea. Okay. If this is the picture that's given to us, and they are asking us, does this picture have a rotational symmetry? Question number 3, we can have a yes, or we can have the two other options, no. Let's see. If I label this as A, B, C, and D, right? If the original shape was this, if we try to rotate this shape, if we try to rotate the shape rightwards, does the shape still look the same? Or if we try to rotate the shape 180 degrees or from the left, okay, does the shape look the same? If I would remove, if this was the red point, it comes over here. If this was red, it comes over here. And if we remove the points A, B, C, D labelings, right? A, B, C, D were the labelings just for our own reference. So if we remove these labelings, can we say that all these shapes still look the same? They do or they do not? Yes, they do look the same. And whenever they look the same, what we can say is, yes, yes, there is a rotational symmetry. Is a rotational symmetry, because the shape, even if someone rotated the shape, the other person would never know that the shape has been rotated, right? So, okay, you have your phone with you. The camera is usually at the top. If you have the screen in the front, the cam is at the top, right? If you rotate the phone 180 degrees, right, upside down, but now the camera goes down. So that means in this case, we do not have a rotational symmetry because the camera is pointing down now, right? So in anything, when you can have the same shape even after rotation, that says it has a rotational symmetry. Okay, we'll try the next question. Okay, yes, exactly the same. Yes, still the same. Thank you. Wherever you point them in the direction, it will still the same. Yes, thank you for the answers. Okay, let's look then at the next example we have. There's a picture of a person in this case. And the next question has a picture of a person. And they're asking us whether this person has a rotational symmetry or no. Okay, if this was the person for us in the question. Okay, question number 4 says, does this picture have a rotational symmetry? Okay, we know that in a person the head is at the top, right? So if we rotate this person, if this person was given to us, and now if the person is rotated towards the right, do they exactly look the same? Even with one rotation, they don't look the same, right? This shape is inverted now. So that means a person cannot be inverted. So in this case, we say there is no rotational symmetry because the shape has changed. Our only thing was it should, oh sorry, I wrote symmetrical, T-R-Y. There is no rotational symmetry, okay? Because the shape has to look exactly the same. Yes. Okay, thank you. Let's try the next question. They have a picture and they're asking us, does this shape have a rotational symmetry? Let's confirm. Let's go with question number 5 from the file. Okay, this is question number 5. And they have a shape for us. It's an abstract shape, and they're asking us whether it has a rotational symmetry or yes or no. So we have the two options. We just need to pick one of the options. Okay. So if we have this abstract shape, logo, let's copy this and let's just try to rotate it. If we rotate right, do they look the same? Or if we give another rotation, right? Sorry, if I rotate like this, are these shape all the same after a rotation? These shapes are not exactly the same, right? Because this part was at the top. Now this part is at the side and this part is now at the bottom, right? So we can say there is no rotational symmetry. Okay. We'll look at more examples where we would find rotational symmetry. Okay. So now the next question says, which of one of these picture has a rotational symmetry? Okay. They have given us three options. I'll break down the question into three separate questions so that it's much more convenient for us. Okay. I'll say this is option A, option B, and option C. Option A, option B, and we'll take this as option C. We have three options over here. Let this be option A, option B, and option C. Okay, in question number 6. So which picture has a rotational symmetry? If we consider the owl in the first picture, right? And if we copy the owl and if we try to rotate it, right? This was the original. If we try to move the owl towards this direction, does it look exactly the same? No, it does not. That means this picture does not have a rotational symmetry. What about two people walking? If these two people were walking, we can say there's a shorter person in front of the taller person, right? But if we rotate them in any direction or maybe upside down, do these shapes look exactly the same? No, they do not, right? But how about this last option? If we have this flower or this shape, and what we do is we marked this position as A. Okay. So if I rotate this, let's suppose if we do a rotation that is towards the right or the left, does this shape still look the same? Or can we say another left? Can we say that this shape looks exactly the same, the third shape, shape C? Yes, because C is a symmetrical shape. Let's see if it's a symmetrical, right? So we can always say that it has to be a symmetrical shape in order to have a symmetry. This is not symmetrical, right? Even though the owl was symmetrical, right? In this picture only, this was symmetrical, but since it has a head, right, and tail at the bottom, so the head cannot go downwards. So yes, the shape C, yes, it is. It has only shape C. Shape A and B would not have. It has rotational symmetry. Good enough. Let's try the next question. And the next question is, yes, C has all the same sides. So even if we rotate C, it will still look the same. Okay. The next question says, which picture has a rotational symmetry? Okay. Sorry, just a minute, please. Okay. It's copied. The next question says, which picture has a rotational symmetry? This is question number 7. Can your hand have a rotational symmetry? One palm. Is your thumb and your pinky the same? If you rotate your hand sideways, the thumb will be upwards or downwards, right? But if you rotate another So the hand, a single hand cannot not have, there is no rotational symmetry in this, right? A crayon we have, but it's diagonal over here. So if we take this crayon and we try to rotate this, okay, if I would rotate this, let's suppose right like this, do both the shapes look exactly the same? No, they do not, because this is pointing downwards and it's going upwards, right? So still no. But what about the last one? If we say that if this was the point that we marked, even if we copy this and we rotate this, right? The shape, irrespective of the marking that I made, right? The shape still looks the same. That means option C has rotational symmetry. Yes, it has rotational symmetry. Okay, thank you. Let's try another question where we can see. Once we click on to the next, we will have the next question. Okay, the next question says that we again have three shapes with us. I'll just copy down those shapes. Okay, which picture has a rotational symmetry? For question number 8, let's see. If this is given to us as question number 8, if this is option A, option B, and option C. Okay, option A, if I mark a reference point in this question, this over here. So if I copy this shape and I try to rotate this shape, if we rotate, let's suppose leftwards, okay? So this shape still looks the same. If I would remove this part, right, the markings that I did over here, even after a rotation, it still looks the same. That means, yes, there is a rotational symmetry. Okay, so let's try the next one and see, next option and see in part B. Do we have a rotational symmetry? If we copy the shape and we try to rotate it, if we have this shape, we copy this and let's try to rotate this. Let's suppose if we just rotate left 90, right? We rotate, so they do not look the same. So we write there is no rotational symmetry, right? Because they are not exactly the same. Yes, option A only has a rotational. Let's look at the last one. Why doesn't this have a line of rotational symmetry? Okay, even though the third shape has a line of symmetry, but if we rotate this, it does not look the same. So we still say, no, there is no line of rotational symmetry in this case, okay? Only option A had a rotational symmetry, B and C do not have rotational symmetry. Moving on to the next question. Okay. Which picture has a rotational symmetry? Okay, let's copy this. And this question says, in question number 9, they're asking us which picture has a rotation. This is option A, option B, and option C. So let's start off with option C first. If we copy this and we rotate this, let's suppose 1/4, right? Do they look the same? No rotational symmetry because they are not the same. Not same, right? After rotation, they don't look same. We carry this I, and let's suppose if we try to rotate this, do they look the same? No, they still do not look the same. So they're not same. Okay. What about the first option? If I'll mark one of these boxes to be this just for the reference. If I'm marking a green over here just for the reference so that we know even after rotation, will it look the same or will it not look the same? Okay. This was the shape and we rotate it like this. Do they look the same? So what option is option? Yes, option A. Yes, it has a rotational symmetry. Yes, there is a rotational symmetry. That means even after rotating the shape looks the same, exactly the same. Thank you for answering. Let's try the next question, question number 10. I'll just copy it. If you are going with me, you can see the question on your screen already on the website. Okay, for the next question, we still have the same, a pattern. Usually a pattern will have a line of symmetry. Okay, so once we have the questions over here, these were the options we have, A, B, and C. Sorry, these were the options we had. This is A, B, and C, right? Okay, let me redo this. If we are talking about line of symmetry in these cases, right, we will look at lines of symmetry, whether all these shapes have line of symmetry, yes or no. Okay, so if we speak about line of symmetry only, then option A, option B, and option C, they have, let's see if they all have line of symmetry. Yes, yes, line of symmetry, in this case also. Sorry, I'll just stop over here. Then I'll make another line. Yes, we do still have a line of symmetry. And in the third case, yes, we do have a line of symmetry. So it's not necessary that if you have a line of symmetry, then you will have a rotational symmetry. Because if we start off with option C, right? If we paste the option C here and we try to rotate it, they don't look the same. No, that means we do not have a rotational symmetry. Not same, right? So they might have a symmetry, but not necessarily rotational symmetry. The option B, if we have option B, which had symmetry, but if we rotate it upside down, it's still not the same. There is no, because these two shapes look different. But what about option A? If we have this, even after rotating this, if this was marked as red, even after flipping it upside down, yes, this has a rotational symmetry because the shapes are same. They look the same. So if they look same, that means even after rotation they look the same. That means there is a rotational symmetry. Agreed? Yes. Okay. Okay. Next. The next question we have is, okay, we have some more questions. Let's have a look. We did this question number 10. We move on to the next question. Okay, I'll give you some more examples. Okay, and we'll see what can be done with these. Okay, then we will go to the test and we'll try a few questions from the test. Okay, let's pick up an option. Let's try some shapes over here. Okay, the first, second shape and the third shape. Okay, I'll just put up multiple shapes and let's see if we have rotational symmetry for the question number 11, right? So if we have this, if I mark this part as a red over here, right? So if I rotate this, copy this and rotate this, would the shape look exactly the same? Is the shape, if I rotate it 90 degrees, does this shape look exactly the same? No, it does not, because in this case, this was shaded And in this case, this is unshaded, right? Agreed? But is it possible that if we rotate this into 180 degrees, now is the shape same, right? So in general, we'll say that there will be a rotational symmetry, but that would be one line only. Yes, it will have a rotational symmetry, yes. But we have to connect these two. In this case, there is, but in this case, no. Okay, if we have this triangle over here, if we flip this triangle, if this was point A, B, and C, if we flip this triangle, can we say that the triangle becomes, if we flip it, it becomes, if we change the sides, can we say that it becomes, if we change the position, A comes here, B comes here, and C comes over here? Question number 12. So that means, yes, it has. The shape is still the same, the triangle, right? So in case of this triangle, we can say, yes, we do have a rotational symmetry. Okay? Yes, we do have. Yes, there is a rotational symmetry. Okay? Moving on further, let's look at the next shape. That would be, if we have this shape, let this be question number 13. Okay? So if we rotate this shape, let's suppose if we rotate this 90 degrees, would this have a rotational symmetry? Does it look the same? No, there is no rotational symmetry, right? Because these two shapes look very different. One is horizontal, the other one would be vertical, right? Let's try the test. Let's do a few questions from the test. Can you please click on the test so that we are on the same page? Okay, I'll pick up the first question from the test. The test is on the right hand top corner. When you click on the test, let's begin with the test. Let's look at the first question, okay? Okay. This is very similar to what we already did. Okay. Okay, they've changed the question into an MCQ. Okay, an MCQ means where we need to find the answer to multiple questions. Let's pick up this ABC. Okay, sorry. I'll just copy this again. The question number 1 says, these are the options given to us. And I'll just bring up the options A, B, and C. And we'll see which option has a rotational symmetry, right? A, B, or C. We did this question previously. So we know that C does not have, this does not have. But if this shape was like this, even after we rotate this, the shape looks exactly the same, right? So we know that shape number A had the rotational symmetry. So this would be our answer. A has rotational symmetry. Agreed? So we can say the first shape has rotational symmetry. The next one, the same question which we had previously. Does this picture have a rotational symmetry? Yes or no? Let's see. The next question we have. Okay. The question number 2 states that this was question number 1, which we did. In question number 2, it says that we have done this similar example already. Can anyone give me an answer? Would this have a rotational symmetry or would it not have a rotational symmetry? Will this shape have a rotational symmetry? Yes or no? Question number 2. Yes, you're saying yes, it has. Rotational symmetry, let's see again. Okay, let's compare and let's see. Okay, if this was the original diagram we had, if we copy this, if we rotate it right side, right, does it look exactly the same? Or if we rotate it towards the left, does it look the same? This was our original, right? If this is the question for us, does it look the same? The arrow is pointing rightwards, it's downwards, and this is downward. So that means if you rotate this, it does not look the same. Yes, thank you for the answer. No, there is no rotational symmetry in this case. Okay, we do not have a rotational symmetry. We did this option also. Okay, the next question we have, we click on to no, and it would show us whether our answer is correct or incorrect. Let's get the next question. It is a pattern. Usually the patterns would have a symmetry, but sometimes they might not have. So let's see in this case whether the question has a rotational symmetry or it does not have a rotational symmetry. In question number 3, just asking us, does this picture have a rotational symmetry? So if this picture was given to us, what we can do is we can paste this. Okay, sorry. I'll select the shape. And if I would say, if this point was the starting point, right? So if I copy this, paste this, and I rotate this rightwards, does it still look the same? And if I do it towards the left, does the shape still look the same? That means irrespective of how many times you turn the shape, it will look the same, right? But you have to, okay? So the shape is same. So you say, you click onto yes. Please do complete your test, right? Next question we have is a person walking. So we need to see if the person walking has a rotational symmetry. That would be question number 4. This question. Yes or no? Very simple. If a person is standing and a person is laying down, it's not the same picture, right? Right? So that means in question number 4, just by looking at the, because it's a person over here, and the person is not standing straight, the person is walking, one hand is ahead of the other hand, right? So we say no, there is no rotational symmetry because the shapes look different. Okay, we click on to no, and let's see the next question. Thank you for answering. uh, we have the next question. We did a similar pattern previously. Let's try this pattern again. The question says, question number 5 would say, does this picture have a rotational symmetry? Can you give me an answer to this? I'll just wait for an answer. If this is the shape given to us, would this shape have a rotational symmetry? Question number 5. Yes or no, please? See, since it's a pattern, since this is a pattern, so even if we rotate this shape, if I mark this point, okay, let's mark it with a different color, orange over here. I select this shape, I copy this. Even if we rotate this left or right, the shape looks the shapes looks the same, right? Even after having a certain rotation on it. So that means whenever we have a shape, yes, thank you for answering. So this means that irrespective of rotation, of the angle of rotation, how many, whatever the angle we rotate, right? It should still look the same. That, yes, thank you for the answer. That means, yes, we do have a rotational symmetry. Agreed? So we are done with 5 questions from the test. Yes. I hope you were answering together. And how many are left? We are done with 5. 5 questions are left, right? So you can always do the test. Okay. Please practice. And if you have any problem, just go through the video again. Okay. Okay. Yeah, it's the same. It's just a revision. Okay. Thank you so much for attending the class. Best of luck. Take care. Bye.